Welcome back. In the last video, we had a look at the different kinds of transfer learning. And we know that we're going to be focusing on feature extraction, but if we had a lot more data, and in fact, you can consider this your extra curriculum, is to look into fine tuning after you finish this module. So let's jump in. Before we prepare our model for feature extraction though, let's just get a summary of our model. This is going to help with the concept behind feature extraction. So getting a summary of our model with Torch Info. This is why in the beginning we made sure to install Torch Info. So if you come up the top, we installed Torch Info up here. This is going to help us get a summary of our model. Let's see it in action, hey? We've got this printout that we got before. This is just the regulation PyTorch printout. But Torch Info gives us a little bit more detail of what's going on with our model. So print a summary with Torch Info. So we're going to go from Torch Info, import summary. We don't actually need to do that again, but I'm just doing it for completeness. The model we're going to pass in here is our model. And then we're going to put in a default input size for what size of our data would we like to pass to our model. 132242224. Now, this is an example of batch size, color channels. So this would be an example of passing a batch of an image of one image, and then height, width. That's the input size we would generally give to our EfficientNet B0. So we also want to put some column names here, col names. Now you see I'm getting a doc string here from Torch Info summary. I've played around with this a little bit before, so we're going to just keep pushing forward. We're going to get an input size column so we can see the shape of our input data. We're going to get an output size column so we can see the output shapes of each of our layers. We'll get a number of params so we can see the number of parameters, the weights and biases for each layer. And then we'll see if the layer is trainable or not. This will make a lot more sense when it gets printed out. Col width equals 20. This is just for formatting. And then row settings is I want to get the var names. And of course, the documentation for Torch Info is on the GitHub. Torch Info, if you'd like to read more about that, thank you to Tyler Yep for creating this. We've got Torch Info documentation there. But let's see this in action. Let's get a summary of our model, which is FNet B0. Oh, beautiful. Look at this. Okay, so here's our EfficientNet, and here's a sequential, which is the features that we just went through. What it's going to do is take in an input image shape with size 1, 3, 224, 224. And the overall output shape of our whole model is 1 and 1,000. That's because if we come down here, this is the output shape here. But essentially our image is going to go through all of these different layers. It's going to be manipulated in shape, input, output, input, output, input, output, input, output. You can go through those step by step if you like. Each one of these layers has a different number of parameters. This is going to mean that as our image goes through these different layers, these parameters are going to hopefully learn something useful from our image. Then we get down to here, adaptive average pool 2D. So you notice that the input shape here is 1,1287.7. That gets compressed into 1,1280.11, then gets further compressed into 1,1280. So this is a feature vector of our single image that is going into the sequential or the classifier head of our model. And then this vector gets compressed even further into 1,000 classes. Where did the 1,000 come from? Well, it's because that this model, FNet B0, was pre-trained on ImageNet, and ImageNet has 1,000 classes. So what would we like to change this to if we're customizing the classifier head to our own problem of pizza, steak, and sushi? We'd like to change this to 3. And of course, that will vary depending on the number of classes that we had. And so if we look at this, is the layer trainable? So right now, all of these base layers are trainable. However, we discussed with feature extraction, if we just jump into original model versus feature extraction, we want to convert our original model, which is currently this, to this. So we want to freeze all of the base layers. So in the next video, let's see how we might do that. In essence, we want all of these to be trainable equals false, and the only layer we want to be trainable is this output layer here, the classifier head. And then of course, we've got some more information here. The total parameters of our model is over 5 million, so far more than our tiny VGG model. And currently all of them are trainable. So we want to alter, especially this value here, the trainable parameters. That will mean the more trainable parameters you have, the longer your model will take to compute. That's another benefit of transfer learning. Feature extraction models are generally quite fast to compute. And then another thing here is the estimated total model size in megabytes. This might not always be the case, but it's something to keep in mind when you go to deploy your model. As we talked about before, we have 3 big considerations for using a pre-trained model. How fast does it need to run? How big is the model in terms of how much storage does it take up? And performance, does it perform as well as you need it to? So the output of torch info.summary gives us a little hint at what the actual size of our model might be. Now, this won't always be 100% correct. Best to just check your model as it appears here when it gets saved to file system. That'll be the actual size of the model. This is just an estimate. So with that being said, we've inspected all the layers. We've discussed the concept of feature extraction. We now know that we want to freeze these layers, use those patterns that our model has learned from ImageNet, and then we want to change the classifier head to suit our own problem. So freeze these base layers and change the classifier head to suit our problem. Let's do that in the next video. I'll see you there.